welcome back to my channel Cat by Nagendra. In this video, we are going to create this bench-wise assembly in SolidWorks. Now let's start here with this first base part. So to create this part, just we'll enter into here new part. Now to create this, we are having here front view, top view and side view. So this is the right side view. Whatever this extra material we are having with this shape, we need to add that. Now let's start here with this base. So on the front plane, we'll go for sketch. From here, one vertical, then one inclined line is there, then one horizontal, again somewhere up to here, then just I'll close like this. Then by using smart dimension, here base we are having here 16, this base we are having here 16, then dimension from this above 16 line to this end we are having here 36. From here to this we are having here 36. Then here 16, again this is 16 and 10. For this vertically we are having 16. For this horizontally we are having 16. This gap we are having here 10. Then total length we are having here 144. Like this. As you can see here, we got fully defined sketch, exit sketch, then we will make it here extrude boss by using mid plane. Total this width we are having here 64 we wanted here. Let's make it here extrude boss of 64 and let's say okay. Like this. Then next to that, here you can see extra material we are having with this shape at this end. So let's go for sketch on this face. Make it normal. Here we need one inclined line, then one tangent arc, again inclined, and we'll make it close here. From here we are having inclined, then go forward and come backward. We'll get curvature up to here, then just we'll close it. For this point we are having here tangency relation. Then this point should be straight to this origin point. We'll make it vertical. Then radius for this we are having here 16. Dimension from base to center point we are having here 36. Then angle we are having between these two of 50 degrees. So this line to this line we are having inclination of 50 degrees like this. Just we can make it line to line equal relation like this. Then exit sketch. We need to make this extrude boss in reverse direction. This shape we are having here only extra material of 22. Let's give this 22 and let's say okay. Like this. Then next we need to remove this material with this cut portion from here. Sketch. Make it normal. Just we'll create this step. Just two steps we wanted here. Somewhere from here, one vertical, one horizontal, again vertical, like this. We will close it. So if you want, we can create half section and we can make it mirror. This to this, we need here vertical relation. This line and this line will make it equal. Then this to this also I will make it equal. Then this to this also I will make it equal. So if we apply relations for one line, if we give dimension, automatically opposite one also it will take. From end to end we are having 32. Then in between we are having 16. For this line, total we are having here 32. For this line, we are having here 16. Then vertical dimensions we are having 7 and one more is 16. So for this we need here 7 and from bottom to top we are having here 16 lines. Then exit sketch. Here you can see this cutout part entire it is mentioned here. In dotted lines we are able to see material should be removed up to last. We'll make it extruded cut through all and let's say okay. Like this material will be removed properly. Then next we are having here fillet with radius of 3 mm. Let's apply here fillet for this edge and this edge with radius of 3 and let's say okay. like this. Then next we can go here with these holes. So here one center hole we are having entire this 22 width with a diameter of 16. Hole wizard we can go for legacy hole with a diameter of 16, depth up to next, position from this face exactly center of this. From here we want, let's say like this. Then one more here, total 4 holes are there with a diameter of 6 and a depth of 10 mm. Here you can see we need here this counter shape with a diameter of 6. Now again we'll go for hole wizard. Whenever we want to create hole with that countersunk at bottom with this normal hole, you can use here instead of simple, we can go here with simple drilled hole. Then diameter we wanted here 6. Depth we will make it here blind, and this depth I need only here 10. Then go for position. From this face we want, let's make it normal. Just we'll create one hole, we can make it pattern. Now for first hole we are having here dimension of this to this only we can take 38. So here extra material side we are taking, it means from here this edge to this we are having here 38. Then here we are having here 44, or else we can take this 10 also. So let's take this 10 from any edge. From this edge to here we need here 10, let's say. Then same hole we need here 4. We'll go for linear pattern with reference to this edge first, then second with reference to this edge. Here what we need to make pattern, feature and face we need to make pattern for this hole. In first direction with reference to this is 70 we are having, here we are having 44. We need here 70 here, then we are having here 44. Let's check this. So total 44. From here this is 64, this side 10 and this side 10. Let's say, so I think this whole position is wrong. Let's check this, how much we did this extruded boss. 74 we did, we need only 64. Let's say properly that holes will be settled here. So just we can create this simple part in this way. So let's apply some color for this and let's save this. Okay, then just we can save it here. We will create one separate new folder under assembly. We are going to create here bench-wise assembly. Bench-wise assembly. Then just we'll make it here base part and let's save it. So just we will close this after saving. Then next we can go here with this part called views and dimensions for wise jaw. So to create this wise jaw, same here also we are having front view, top view and side view. So just in front view directly we can't create these two shapes. So let me start here with side view. Now we'll go for new part. Then on the front plane or any right plane also we can use. Let's go here with front plane only. Just I'll create this L shape. So from here we need one horizontal vertical plane like this. Then one more step we wanted here. So here you can see extra material bottom side we are having only with this shape. So if you want total we can create, later we can make this cutout or else just from here only we can do. Now let's create only this much. So just we need only like this. Then by using smart dimension here, total width we are having here 32. This width we are having here 32. Then this height we need only 10 mm. This height we need 10. Then again here also width we are having here 10. So this also we need 10 like this. Then height from this to top we are having here 36. So from here to here we are having 36. Exit sketch, isometric. We'll make extrude boss by using here mid plane. Total width we need here 64. Let's give this 64 width and let's say like this. Then next we are having here same this shape as we have created before. We'll go for sketch, make it normal. We need one incline line, then go forward and come backward. We'll get curvature. Then from here one incline line, we'll close it. This center point to origin point we need here vertical relation. Line to line also we need here equal relation. Dimension for this curve we are having radius of 16. Then distance from this point to this point we are having 55. So this length we are having 55. Here we are getting error. Let's delete this radius and let's give it later. We need here 55 like this. Then this curvature should be tangent to that. Let's make this relation between this to this. We need here tangency and still it will be able to move. Now let's try to give this radius of 16 like this. Exit sketch. Then we can make it here extruded boss up to next. So up to here material is there, or else total also we can do. So extruded boss in reverse direction will make it up to next. Up to there only material will be added like this. Then later we can add this extra material with height of 9, width of 16. Material should be added this entire length of 32. Here again we'll go for sketch. Just we need one rectangle here. Then this line to this line will make it here collinear. Center point to origin point will make it here vertical. Then this height is 9. Then this width we are having here 16 like this. Then exit sketch isometric will make this extrude boss in reverse direction with a length of 32 and let's say okay like this. Then next we are having here fillet of radius 3. Let's apply fillet for this edge and this edge with only radius of 3 and let's say okay like this. Then next we are having here final poles. So here from bottom we are having here two poles with diameter of 6. Then depth we need here 16. Here also we are having here this at far side we are having this P-shaped bottom. Now hole wizard we need here simple drilled hole. Diameter we are having 6 with a depth of 16 with same this drill angle. Go for position. Here we want make it normal. We need one here and one more here. Then this hole and this hole and this hole will make it horizontal relation. It should be straight. Then from this edge to we are having here 8. From this end to this we are having here 8. Then this hole to this hole we are having here 16. Let's say okay like this. Then one more hole we are having here diameter of 6 through. This is the symbol for counter bore. Counter bore diameter we are having 10. Then counter bore depth we are having here 4. You can see counter bore hole shape. We need to create this counter bore on this. Now hole wizard we need here counter bore. Counter bore diameter is 10, depth of 4. Normal hole diameter is 6. Here depth should be through all. Counter bore diameter we are having 10. Counter bore depth we are having 4. Go for position. Whenever we are having these curvatures, we should not take support of the curvatures. Just we need to take any flat faces. If we are not having any flat faces with reference to that, separately we need to create reference elements. Then only we can create that hole. Why? Because on curvature, if we create this hole, that position either it may be this move this side or that side. So it won't get proper position. Better to select this flat faces for reference. So we need somewhere here. Let's make relation between these two. We need here horizontal relation straight. Then dimension for this position we wanted from edge to center we are having 20. Let's give dimension from this edge to this center point we need here 20. Fully defined, let's say. So here like this we can create this. You can see up to next only it will be removed. So let's create this one more hole here. Now just I will hide this. First we will create this, then only we can get up to next. Here diameter of 12, depth of 24 we wanted here. Diameter we need 12, depth of 24, position exactly center of this curvature from here. Let's say okay. Then just I'll show this. We'll go for edit feature. We'll make it here depth up to next. So up to that next support only material will be removed like this. So let's apply some color for this and let's save this. Okay. Then just save. Under this we are having here wise chart. Let's save it. Then just I will close this. Next part we can see here a small plate is there, base plate. Just we are having 20 into 144. Let's finish this part. On the top plane I'll go for sketch. Just we wanted one rectangle here. Dimension for this we are having width of 20, length of 144 like this. Then just two countersunk holes were there. So we will make this extrude boss of 6. Okay. Upon that we are having here countersunk hole. This is a symbol for countersunk. Diameter of 7. Then angle of 45 with a depth of 3. Hole wizard. We want here countersunk hole. Here diameter we are having 7. Then depth of 3. Depth we wanted here 3. Angle of 45 degrees. Diameter we are having here 7. Then depth up to next. Entire thing we can create here. Then countersunk diameter we wanted, but here we are not having any diameter. So in these cases, just directly we can go for sketch, make it normal. Wherever we wanted, just we will create here 2 circles. Now dimension for this circle, you can see diameter we are having here 7. Let's give this circle diameter of 7. Then this one and this one will make it here equal. Then to make position from this edge we are having 38 and hole to hole we are having 70. So from this edge we are having here 38. Then hole to hole we are having here 70. Let's give relation between this point and horizon point, and this will make it horizontal to make it fully defined. Then with this sketch we will make it here extruded cut through all like this. Why means, so if you want to create countersunk hole by using hole wizard only, we wanted here countersunk outer circle diameter also, but we are not having here, only angle is there. So with it, this diameter of 7 we made through, then here 45 degrees with a depth of 3 mm. Let's apply chamfer for this. with 45 degrees with a length of 3 mm, and let's say OK. Properly we will get that countersunk shape. Then let's apply some color for this part also, and let's save it. So this is base plate. Let's save it. Then just I'll close it. We can go for next part here. So next we are having here jaw screw, very simple part. We can create only half section and we can make it revolve boss. So we'll go for new part. On the front plane we'll go for sketch. Now let's start from here. Just one step here. Then it should be equal to this. One horizontal. Then one vertical. Then straight to this. We are having one more step here. So this line should be straight to this. You can see, just we can make it like this, straight to that. Then one more horizontal. Again, just one step, one more here, straight to this. Just go forward and come backward. We'll get again line. One line from here straight to this. Then just we'll draw here up to this and we'll make it here close. Then by using smart dimension here, we'll start from here. First circle diameter we are having 12, as we have created only half section, we'll make it only half 6. For next we are having diameter of 8, so this to this I'll give here 4. Then this one it should be straight to this. Let's apply relation between this and this and this. We need here collinear straight to each other. Then next we are having here bigger circle diameter. This is 16 and this is 18. So this to this we are having here 16. Then 16 by 2 we need only 8. Then this is 8, 18. So we'll give only half of 9. Then horizontally we are having 7 and 6. So here we need 7. Here we need 6. Then next total length we are having here 138. Let's make it here total length of 138. Then next from here we are having this gap of 10. So this is 24. This side we need 24. Next we are having here only 10. Then in center part we are having here length of 82. So from this to this we are having 82 like this. Exit sketch isometric will make it revolve boss with reference to the center line. Let's say OK. Like this it will be created. Then next we are having here one hole with distance of 12 with a diameter of 6 up to last. So exact here we need to create one hole. So we don't have any proper reference here. Why? Because we are having curvature. So if you want, we can create hole, or else directly we can go for sketch on the front plane. Just we can create one circle here. Dimension for this we are having diameter of 6. From this end we are having distance of 12. Then the center point to origin point will make it horizontal relation. Exit sketch isometric extruded cut by using mid plane. Just we can tag that properly. Material will be removed like this. So let's apply some color for this. So this part name jaw screw. Let me apply some color and we will save it as jaw screw. Save jaw screw. Let's save it. Then Next we can see here one more bar globes. So for this bar globes, just I'll go for new part. On the front plane I'll go for sketch. So here only half section we can draw with radius of 6 mm. Just by using center point arc from here to here I'll create one arc. Then to make it closed profile I'll draw one line here. Dimension for this we are having radius of 6. Then let's try to drag that. We'll make this to this coincident. Exit sketch, isometric, then revolve boss with reference to the central axis like this. Then again on the front plane we'll go for sketch. We needed only this part. So just we can remove that extra material. So this total length we are having here 9. So in single sketch also we can complete here. Instead of drawing this full bar globe like full circle, just I'll draw one line somewhere here. Then one more line also we can draw here. By using trim entitles, we can trim this extra and unwanted elements. Then this line and this line will make it equal. Length for this we are having only 9, so we needed only length of 9 like this. Then exit sketch, directly we can get that shape. In that we are having here countersunk hole. So here normal hole diameter is 4, then with a depth of 1, just we need to make that. So just let me create one normal hole with diameter of 4. Depth should be through all. Position from here exactly from origin. Okay. Then just we'll apply one chamfer with 45 degrees with a length of only 1 mm. Let's make it here distance only 1 and let's save it. So we'll apply some color for this too and just we can save it. This is bar globes. Let's save it and just we'll close it. Next we'll go here with this screw bar. So same similar to earlier part, just we'll go for front plane. Here also just we can create half section and we can make it revolve boss. From here one vertical, horizontal, then one more vertical, just straight to this like this. From here we wanted one vertical line up to here. Then by using smart dimension here, small circle diameter we are having 4, so just we'll make it here 2. Then this line should be straight to this, we'll make it collinear. Next this bigger one we are having 6, so this to this 6 by 2 3 we will give. Then this gap is 10, this gap is 10, so this is 10, same equal to that, it should be 10. We'll make it here equal relation. Then total length we are having 104. Let's give this length of 104. Then exit sketch, revolve boss with reference to this. Let's say okay. Then let me apply some color for this. Okay. Then let's save this as screw bar. Screw bar saved. Then we'll close this and we can go for next. Oval fillister. So here also we can create half section. We can make it revolve bars. Very simple parts. On the front plane. Here just one vertical line I'll take. Then from here one smooth curve we want. So let's make it that with a 3-point arc later. Then from here we need this step. One horizontal, vertical, one more horizontal up to here. Then one more horizontal. Just from here I have created one vertical, then one horizontal, then Here also we need one more horizontal line, then one more vertical. From here we needed one curvature. It's created by using 3-point arc from this to this like this. Then by using smart dimension, bottom we are having diameter of 4, only 2 we will give as we are creating only half section. Next we are having 6, so from this to this 6 by 2 will make it 3. Then vertically we are having from this to this we are having 1 mm. Then this gap we are having here 2. This is 1. Then this gap we are having here 2. Then outer one we are having 10. So this to this 10 by 2 will make it 5. Then from this to this we are having 7. From this to this we are having here 7. Let's move this curvature up like this. Then just we needed extra dimension of this radius of 6 mm for this curvature like this, but still it will be moving. As you can see, freely it is able to move, but here we don't have any total height, so just we can make it the center point coincide on this line like this. Then exit sketch will make it here revolve boss with reference to that. Then on the front plane we'll go for sketch, make it normal. We need this cutout of 2 into 2. Just we'll create one rectangle here. Then dimension from this we are having 2 and width of 2. From this to this curvature we are having here 2. Or else we can consider from here also. So dimension from this to this we wanted here 2. Let's keep it here like this. Then by using this point we will drag and we'll keep it wherever we want. We need on this curvature. Let's click there. This point for this dimension, it should be from here. Let's keep it here. So it is not possible to make it here properly. So what we can do is this curvature we can convert entities, then we can give dimension from there itself. Let's delete it. Dimension from this point to here we are having 2. This one will convert into construction. Then the center point and this origin point will make it vertical relation. This extra material how much we want we can keep it, or else we can trim this one also. So just we can trim this like this. This extra we don't want. This point also we don't want. In a simple way we can create, or else in this way also we can make it. Let's make it equal. This one will turn off construction and we need to trim this. We need to trim this. Then if we try to move, it is able to move like this. This width also we are having 2. Only that part also we can make it, and we can make it here extrude cut by using mid plane. Say okay. Or else extra we can take it and we can close it there itself. So just we'll apply some color for this and let's save it as oval lister. Let's save it. Then I'll close this. Next we can finish here. Extra 3 parts are there. So set screw 2 we are going to create. Same half section revolve boss cutout. On the front plane. Sketch. From here. One vertical. One horizontal. Then one inclined line straight to this. Then one more inclined line here. Then outer one we are having 13. So 13 by 2 we will give. Bottom we are having M6. So this to this dimension will be 6 by 2, 3. Inclination we want 120 degrees. So this to this we can make it here 120 degrees. Then for this we are having height of 5. For this we are having height of 5. Then for this to this we are having 18. This to this we are having 18. Exit sketch. Revolve boss with reference to the central axis. Then on the front plane we'll go for sketch. Make it normal. Just we wanted one rectangle here. Then for cutout dimension we are having 2 into 2. Width we need here 2. Height we need here 2. This line should start from here. Make it here collinear. This center point it should be straight to origin point. Let's make it vertical. Exit sketch. We'll make it here extruded cut by using mid plane. Just we will drag extra and we'll clean it like this. Let me apply some color for this and let's save it as set screw. Then one more part, set screw 1 we are having here, same similar to that, difference with height. So if you want, just we can make it reverse to that, but here dimension also not there. Let me open that recent part. Now this cutout dimensions also 2 into 1. Let me edit this. This height only 1 we wanted here. Then this sketch, make it normal. So this is entire thing okay, and this change is 13. Here 5 we don't have, we will delete that. Then instead of 5 we are having 45 degrees inclination here. Let's make it angle between these two. We are having here 45 degrees. Exit sketch. Then instead of saving here, we will go save as. Save as set screw 1 and let's save it. Then close it. Then next we are having one single plate, clamping plate. So for clamping plate we are having here 32 into 16, 32 into this height is 32. Then width we are having 8 plus 8, total here also 32. On the front plane I'll go for sketch. We need one rectangle here. Dimension for this we are having 32. Same, this one should be equal to this, we'll make it equal. Along with that we are having here this countersunk with 60 degrees. So same here also we will draw one circle diameter of 7. Let's make it here equal, and all these 3 points should be horizontal. Dimension for this circle we are having 7. Then distance from this to this 8 and 16. So this to this we need here 8. Then this to this we need here 16. Exit sketch isometric extrude boss of 7 we wanted here. Okay. Then to create that countersunk 60 degrees depth of 5. So we'll go for chamfer here. Inclination we need 60 degrees with dimension of 5 for this edge and this edge. Like this. But here cross step we are having here. So instead of making here 5, let's make it here only 3 and let's say. So usually they will specify countersunk diameter also, but here they have not given. So we are assuming our own dimensions and we are making here. Then let's save this. So we are having here clamping plate. Let's say now let's create this assembly design. For that Let me call here this base part first. So just we'll enter into here assembly, and first we need to insert this base. Open, we'll keep it here. Then next we are having here base plates. So insert component, we'll call this base plate. We'll keep it here. Then here one thing we need to observe that on one side we'll be having less distance, on one side we are having more distance. So if I check dimension from this edge to this hole, we are having here a distance of 33. Whereas if I check from this edge to this, we are having here 35. Same here also we need to check. This edge to this hole, we are having 35. Then this to this, we are having here 32. So it means this one, it should get assembled here, should get reversed. Now we'll make relation between this hole, it should be coincide with this, like sorry, concentric to that. Then this hole, it should be concentric to this. Now you can see properly the two, it will be aligned, and here also it will be equal to each other. Then this face, it should attach with this. Why? Because this counter shape should be in opposite direction. This to this will make it coincident in reverse direction. And let's say okay. Like same base plate, we need one more here. Instead of calling one more, we can go with copy with mates. First concentric to this hole, next concentric to this hole, coincide to this face. Let's say okay and cancel at end. Then downside we need here screws, set screws. So to check which screw it will align, here this height is 10 mm. Then upon that we are having here under we are having distance of 6. So total 16. In that 16 we are having only 3 consideration. Why? Because this 3 mm will be of counterbore. So it means total we are having only here 13. So for 13 height we are having here set screw 1 is there with the height of 13. So we need to call that set screw 1 and we need to assemble it. So insert component, set screw 1, open it. Let me make it reverse direction here like this. By using mate, this one, it should be concentric to this. Let's say okay. Then this face, it should be straight to this after inserting. Let's say okay. Then here rotation will be there. To lock that rotation, I'll select this cut part. It should be parallel to any face we can select. And let's say okay. Then same screw, total we need here all 4. We can use here copy with mates or else directly we can go for pattern. In this direction, reverse direction with a distance of 70. In this direction we are having 44. Let's okay. Like this. Bottom assembly done. Then next we can insert this part. So let's call that one more part. So that part name, let me check here. We are having here wise jaw. Open that and keep it here. We need mate. Now this face, it should attach with this face. Okay. Then this face, it should slide with reference to this. Okay. Then here you can see this little gap is there. So this to this face, let's create some gap by using here distance mate. Let's apply some 10 mm gap and let's say okay, like this. Then next we are having here this bar screw bar. So insert component, we need here screw bar. Sorry, this is bar globes, base plate, jaw screw. Yes, jaw screw we need to call. We'll keep it here. Mate. This one, it should be concentric to this. Let's say okay. Then this face, it should attach with this inside face. Let's say okay. Then next we are having here rotation for this jaw screw. Like this, it is able to rotate. So if you want rotation, we can keep it like that, or else we can lock that rotation also. Then next we'll call here this olivister nut. So oval philister mate. This one concentric to this. Let's say okay. This flat face, it should be attached with this flat face. Okay. To lock rotation, this cut part, it should be parallel to this. Let's say okay. That will be fixed. Then next we wanted here this screw bar. Let's call that screw bar or bar screw. We'll keep it somewhere here. We need this to this concentric relation like this. Then here it should be straight to here, exactly at center. For that purpose, here we are not having any planar, so it is with inclination. So here just I will show this axis. Then we can give dimension from this axis to this edge like this. We need here distance. So how to give the distance means we need to check how much distance is there of the screw bar. Total 104, will make it 104 by 2. So we want a distance of 104 by 2. It will come exactly at center. Let's say like this. Let me hide this axis. Then next we are having here this bar globes on both sides. So we wanted this bar globes made. So if you see in assembly, one side we are having counter shape. So we need to check that counter shape in which way it should come. So this is the normal one cutout made. This one, it should be concentric to this. Let's say okay. Then this one, it should be attached with this in reverse direction. So it should be reversed. This face, it should attach with this face in reverse. Let's say okay, like this, or else we can make this to this also. Anyway, we can use here. So let me drag out. We'll make just a simple relation between this to this. Let's say okay. Then still rotation will be there. If you want, we can lock it, or else we can leave it like that. Then we want here one more copy with mates, concentric to this, coincide to this. Let's say like this, we can create this one. Then next we need here clamping plate. At bottom we will be having clamping plate. Insert component. We want here clamping plate. Let me rotate that like this. Mate. This hole, it should be concentric to this hole. Okay. This hole, it should be concentric to this. Let me drag this part out. So we want relation this to this. Okay. Then this plate, it should sit here. So this face I'll select and this face I'll select. Properly, it will sit there. Then for that we are having one more set screw of length 17. So let's call this set screw 2. Let me make it here reverse. Then by using mate, this one, it should be concentric to this. Okay. This face, it should attach with this. Okay. Then to lock that rotation for this screw, just we can select this cutout part, this to this we can make it parallel. Same like this, we need one more. We can go here with copy with mates. Think some error is there. Okay, this one. We can go here with copy with mates. Next, concentric to this, coincide to this, parallel to this. Okay, cancel. So properly this assembly will be finished. If you want to move this, we have given here distance of 10 mm. We can delete that, or else we can suppress that. Just it will move this. Like this we can use. And here also it will get rotation. And we can adjust this screw mate, we can apply here with reference to this, and we can give minimum and maximum limits. Automatically it will get rotation. But I think up to now only our video is very lengthy, so I am not including in that. So just we are making proper assembly design like this. So I hope you have liked this video, and if you have any suggestions for me to give, please just mention in my comment box. And thank you so much. Thanks for supporting. If you really like video, please like it and share to your friends to whom it will be useful. Thank you so much.